Assalamualaikum. My name is Asmazul Shazwina. In this video, my group will conduct an experiment of water quality. There will be 3 different designs of purification system in order to perform significant analysis required to measure effectiveness of the design system. So, let's go to the video to see how the experiment will be conducted. Water quality can be defined as a chemical, physical, and biological characteristic of the water. Polluted water that cannot be used for drinking, showering, industry, or agriculture effectively decreases the amount of water in the given environment that can be used. The biological or chemical change in the quality of water due to the presence of contaminant in water is called water pollution. Most of the contaminants as on there is due to various of human activities. In fact, humans are responsible for the pollution that happen in this world. There is an urgent need to look into measures to control water pollution, although a lot of effort and scheme has already been announced by the government in this regard. The water which drink daily looks clean, however, it is contaminated with the microscopic pollutants. Many families have installed water purifier at home to ensure their family member gets to drink healthy water.
In this mini project, the task is to do a model design of water purification system with 3 different parameters. Our group have decided that the design parameters will have the differences in terms of enrichment and the depth of materials, which consists of sand, charcoal, aggregate, cotton pads, and cloth. We will be observing the physical and chemical characteristic of water, which comprises of the color, smell, turbidity, and pH value. This is the reference of the scale for the 4 parameters that gonna be used in this testing. For the first design, I will be used the measurement of 4 cm of materials to make the water purification system. The material needed is cloth, cotton wool, fine sand, charcoal, coarse sand, and gravel. To make water purification system, we need tap water and soil to make synthetic wastewater as a replacement of real wastewater. First, put the soil into the 1.5 liter of water and then shake the bottle well to make sure it is fully soluble. Then it is ready to be used. So, this is the water bottle that has been marked for 4 cm each division. The cloth will be fitted onto the tip of the bottle and the cotton pad will be inserted into the bottle as the bottommost layer. The first material that will be put into the upside down water is fine sand. The second will be the crushed charcoal. Fine sand again for the 4 cm and then coarse sand, and the outermost layer will be the gravel. Shake well the synthetic water and then pour it into the purification system carefully. Don't let it spill. Then let's wait to see the result. This is the water that coming from the water purification system, and this is the final look of the system. Here you can see the differences in color between synthetic water and wastewater. So here is the testing for the order for synthetic water and wastewater. Turbidity test: synthetic water recorded for 100 JTU, and then the wastewater recorded the value of 60 JTU for turbidity. For the one and only physical characteristic parameter used is pH value, it is recorded that in synthetic water, the value of PaHU is slightly acidic than the wastewater. The wastewater recorded the pH value of 7, which is having the neutral pH. This is the final result for design 1 that having the measurement of 4 cm of material used to complete the water purification system. This result is made by the comparison to the synthetic water as the control variable.
Hello and good day. My name is Francis Nicholas, and today I will conduct our water purification system for model number 2. Firstly, we needed to prepare the synthetic water. We needed 1 liter of water and 1 teaspoon of soy.
Gravel, charcoal, coarse sand, fine sand, cotton wool, and cloth.
After that, we are going to prepare our water purification system.
So here are the materials for the design tree. First of all, there is charcoal and it needs to be crushed. And there is a coarse gravel, coarse sand, fine gravel, cotton wool, cloth with the band, jar to capture the water, and plastic bottle. First of all, I'm gonna mix the water with the mud and stir it. Cut the bottom of the bottle. Then measure and mark the height for each materials. Then place the cloth and tighten it with the band at the bottom of the filter. Next, place the cotton wool at the bottom and tighten them. Next, add as height as 3 cm for each material, starting with the charcoal, and then fine sand, coarse sand, charcoal again, fine sand, coarse sand, and lastly with the gravel. So here is the final look of the filtration. Place the water filtration on top of the jar so that the jar can capture the water. And then pour the dirty water into the filtration. So here is the filtered water from the water filtration. And for the physical parameters, I'm using turbidity chart to measure the turbidity of the water. Here is the result for the unfiltered water, which is 100 JTU. And here is the result for the filtered water, which is 40 JTU only. Other than that, I'm using universal test paper to measure the pH value of the water. Soak the test strip into the water. The pH value for the unfiltered water is 6, which is categorized as lowest acidic. And the pH value for the filtered water is 7, which is neutral. Besides, the color for the filtered water is clear while the unfiltered water is quite brownish yellow. Other than that, the odor for the unfiltered water is considered as strong smell while the filtered water has no smell.
To conclude, here are the picture of before and after for the water purification process. For design 1, the filtered water is much cloudy compared to design 2 and design 3. Then the most clear water can be seen after filtration is design 3. As shown, the best result must be design 3 since it contains more layers of material, which are 2 layers of sand and charcoal, at the height 3 cm each. The smallest pores between the material will give the better outcome because the suspended solid will stay at each material. Hence, clear water will be obtained. Thank you for watching and stay safe.